In our new unit, we're going to be learning about weather. For these video notes, you will need the following: a highlighter, a red color, a blue color, and your normal writing utensil. If at any point you need to catch up on the notes or the drawings throughout the video, go ahead and pause the video to catch up. The first thing we're going to do is learn about uneven heating. If you haven't already, title the next blank page in your journal, Uneven Heating Notes. We've talked about uneven heating before when we've talked about seasons of the earth. Let me change my pen color here. So what I'm going to do is we're going to make a drawing here. It can take up most of the page if you would like, but I'm going to draw the sun. And then I am going to draw the earth. And remember, we learned about seasons that the earth is tilted. So it's not the best drawing. If you know me, you know I'm not an artist. But we talked about the main areas of the earth. So what do we call this middle line that divides earth into north and south? Yeah, this is our equator. So let's go ahead and label this equator. At the top, we have our North Pole. At the bottom, we have our South Pole. When we talked about seasons, we talked about direct and indirect light. That the earth receives light from the sun that is really intense in some areas and less intense in other areas. Some of you might have done a lab with a flashlight, learning the difference between direct and indirect light. We said that direct light is more concentrated like this, and indirect light is more scattered like this. Okay, so when we're looking here at Earth, those areas, just to remind you, near the equator, they receive direct rays from the sun. So the energy that they receive and the heat that they receive from the sun is going to be intense. The poles, they receive less intense rays or indirect rays from the sun. So I'm going to go ahead and label that. Because the energy near the equator is so intense, the energy we get from the sun is so intense, that's going to make temperatures near the equator warm. So go ahead and grab your red color, and we're going to label that area near the equator in red. We're going to label it warm. Because the energy at the North and South Pole is less intense from the sun, I'm going to grab my blue color, we're going to label those areas cold. So remember, we talked about that's why it's cold at the poles and warm at the equator. Now we've also looked at convection, and we talked about how warm particles are less dense, so they rise, and cold particles are more dense, so they sink. This is happening in the air and in the water. So we looked at it on a small scale. On a global scale where the Earth is, what we see is that warm water from the equator is actually going to travel up to the poles. Warm air and water from the equator travels up to the poles. And cold air and water from the poles travels down to the equator. It's continually circulating in convection. Okay? So this is happening all the time. So I'm going to grab my pen or pencil. I'm going to zoom out a little bit here. And we're going to make some notes, okay? What we have to remember is this. Warm air and water moves from the equator to the poles. So warm air and water moves from the equator to the poles. Cold air and water moves from the poles to the equator. This constant circulation of warm air and water moving from the equator to the poles and cold air and water moving from the poles to the equator is circulating the heat energy around the Earth. It's actually making our temperatures more mild. So that way it's not just real hot in one area and real cold in another area all the time. So it's circulating that air and that water. That circulation is what's going to help create wind and weather patterns, which is what we're going to look at today. Pause the video now if you need time to catch up. Okay, one last thing that I forgot to mention, I'm going to grab my highlighter here. I want you to go ahead and highlight this information. Warm air and water moves from the equator to the poles. Cold air and water moves from the poles to the equator. Go ahead and highlight that, and then we're going to move on to our next notes page. Okay, now that we're ready to move on, go ahead and grab the paper that says, "What is wind?" We're going to do some highlighting and some drawing here. We are also going to need our highlighters, red and blue colors. So I'm going to grab my highlighter. One thing that I need to know is that wind is caused by changes in air pressure. So we're going to look at air pressure today. Wind is caused by changes in air pressure, so go ahead and highlight that. Air moves from areas of high pressure to areas of low pressure. So what we see happening is when we see wind being created, go ahead and write this down. Wind is basically air moving from high pressure to low pressure. Now I'm going to grab my highlighter and I'm going to highlight that. Wind is moving from high to low. So here we see that word convection again. Remember we looked at this. Convection in the air occurs when warm air particles have space to move around. They are less dense, so they rise. So I'm going to highlight warm air, less dense, rise. Cold air particles are packed tightly together. They are more dense, so they sink. I'm going to highlight cold air, more dense, sink. Now we're going to draw some pictures of this. I want to look here at high pressure. I'm going to grab my blue color, okay? High pressure, you will see high pressure represented by a big blue H. So I'm going to write a blue H next to this. High pressure is going to be cold air. So I'm going to write the word cold next to this. Cold particles or cold air means that they are packed tight. So it's cold, it's packed tight, and it's more dense. So this is just from that sentence above. So what this looks like, if we were to draw what those particles look like, they're really packed tightly together. I like to think of this as penguins. Penguins live in cold environment. High pressure is cold air. Penguins live in cold environments, and in order for them to stay warm, they have to huddle together real tight. So it's like a whole bunch of penguins that are huddled together. That's high pressure. So remember, high pressure is going to sink down because it is more dense. Those particles are really close together. Now I'm going to grab my red color. Let's talk about low pressure. So low pressure is represented by a red L. And this is going to be warm air that is spread out and it's less dense. Warm air that's spread out and it's less dense. So if we were to draw a picture of what this looks like, all those particles are spread way far away. It's like when you've been outside running around all day and you're really hot and sweaty and you don't want people to touch you. That's kind of how low pressure is. Those particles don't want to be anywhere near each other. So when we put this into convection, what we see here, I'm going to grab my pen or pencil. Let's pretend that this is Earth's surface, okay? So here is Earth's surface. Here's the sun. The sun is radiating or sending waves of heat to the earth. It's hot. Okay? What happens is the surface of the earth is going to start to heat up like this. Surface of the earth starts to heat up. Okay? As that surface of the earth starts to heat up, the air is going to get warm. So I'm actually going to grab my red color and I'm going to color this arrow. It's a terrible coloring job, y'all. I'm going to color this arrow red, okay, because this represents our low pressure, okay? So I'm going to write a big red L right here. This is low pressure. And remember that low pressure is going to be less dense, so it rises up. The heat from the Earth's surface heated that air. It's less dense because it's warm, it's spread out, it's going to rise up. And as it gets further away from the surface of the Earth, it starts to cool off. And as it starts to cool off, those particles become packed tightly. So I'm going to grab my blue color here, and I'm going to color this area blue, this arrow blue. Okay, those particles are going to cool off, and then this is our high pressure. It is sinking air because those particles are cold, they're packed tight, they're going to sink down to Earth's surface. And then once they get to Earth's surface, they're going to heat up again, become less dense, it rises in low pressure, it cools off, it sinks back down into high pressure. So that is the basics of what we see with wind. So if you look, I'm going to grab a different color highlighter here, and you do not need to highlight this. This area that you see right here, this is wind. Wind is where that high pressure goes into low pressure. We said it moves from high pressure to low pressure. So this area that you see right here is where we experience wind. And if you think about wind, wind feels cold to us most of the time. In Texas, it's kind of hard to feel that. But most breezes are going to feel cooler than the temperature around you. That's because that high pressure is sinking in, that air is sinking in to fill in the space of the low pressure. All right, let's move on to local winds. Grab your highlighter. Energy from the sun heats up the earth, causing changes in pressure. These changes in air pressure result in convection currents that create wind. Here's what you need to highlight that's super important. Land changes temperature faster than water. This means that land heats up and cools down faster than water. So what we're going to be looking at now is a land breeze and a sea breeze. So I want you to think about if you've ever been to the beach, like Sylvan Beach, for example. Okay, in the middle of the day, what does the sand at Sylvan Beach feel like on a really hot day? If you said hot, you are correct. That sand is really, really hot, and sometimes it's so hot that you have to run to the water to cool off your feet. Okay, so during the day, the land actually heats up really, really fast, which is why the sand gets really, really hot and the water stays cool. Okay, at nighttime, the land cools off really, really fast. So the sand, once the sun goes down, it starts to get cool while the water is still warm from the day. So definitely something you need to remember here. This right here is going to be really, really important. This is definitely something that you need to memorize. Okay, this is important information here. So we're going to look at two types of breezes. Okay, two types of wind here. We're going to look at land breezes and we're going to look at sea breezes. So I want to skip down to the bottom and look at sea breezes first. So I'm going to grab my pen or pencil and I'm actually going to circle the word sea. Winds are named from where they originate or where they come from. So if it's named sea breeze, then it means it comes from the sea. What do you notice about this picture that you see here? What time of day do you think that we're going to experience a sea breeze? If you said daytime, you are correct. So I'm going to write this down here, and you're going to need to write small. So I'm going to write daytime. And in the daytime, is the land going to be hot or cool? Good. So in the day, the land is hot. And if the land is hot during the day, then the water is cool. So something important for us to remember. In daytime, the land is hot and the water is cool. So I'm going to draw a simplified picture of this here. So I'm going to draw my land. Here's my land. And there's my water. Okay, so this is the same exact picture that you see here, just simplified a little. During the day, the sun, let's draw our sun here real fast. During the day, the sun is going to heat up the land. So the land starts to become hot. Okay, so let's draw some little arrows there for heat. And if the land becomes hot, what happens to the air above the land? Yeah, it's gonna rise and it's gonna heat up like this. Okay, remember that this is low pressure. So I'm gonna write an L and then I'm gonna write warm air. As that air starts to get over the cool water, what do you think that air is going to do? Good, it's gonna cool off and it's gonna sink and it's gonna fill in that space there of the rising hot air. It's gonna fill in that space and it's going to create a breeze. So remember, this is our high pressure, this is cool air, and when that cool air sweeps in and replaces the warm air, that's where we see a breeze. So this is what we call a sea breeze, where the breeze is coming from the sea. The land is hot and the water is cool. Let's talk about land breezes. So I'm going to zoom in here. What do you notice about land breeze? Let's actually circle the word land here. Where would the breeze come from if it's a land breeze? Good, it comes from the land. So what do you notice about the time of day of a land breeze? Good, it's nighttime. Is that how you spell nighttime, guys? Maybe it's just one T. Let's just write night, because if you know Miss Summers does not know how to spell. Don't tell your English teachers. Okay, at nighttime, what does the land start to do when the sun goes down? Good, the land is cool, which means that the water is still going to be warm. So the water is warm and the land is cool. Remember, the land heats up and cools down super, super fast. It takes the water a really long time to heat up and cool off. So I'm going to draw my little simple picture here. Here's the land. Here's the water. So remember that this is nighttime. And at nighttime, the water is going to be hotter. So we're going to see that heat starting to rise from the water. So the heat from the water is going to heat up the air above the water. So this is our low pressure, which is our warm air. And as that air gets over the cooler land, it's going to start to cool off. It's going to sink down and it's going to fill in the space of that rising warm air. So this is our high pressure, which is cool air. And then here is our breeze. And that is how wind is created. One last thing I want us to do, I'm going to grab my